Hi, we are on question 12. So we need to rearrange this formula to make W the subject. First of all, I just want to look at what's happening to W. So W is being highlighted, apparently. Let me choose an appropriate pen. It's being multiplied by 2, and then 2H is being added to it. So we need to do the opposite and the reverse of that process, which would be take away 2H and divide by 2. So the first step is to take away 2H, and that has to happen on both sides. And then we divide throughout by 2, giving us P take away 2H divided by 2 equals W. Question number 13. So Ellis has 28 meters of ribbon and they cut the ribbon into lengths of 60 centimeters. So 2,800 centimeters divided by 60 centimeters. This will tell us how many of those lengths of ribbon we're going to get when we cut them up. So that gives us 46.6 recurring, which means we can't make 47. So we've made 46 lengths. Okay, let's find out the distance of those 46 lengths. So they're going to be multiplied by the 60. So 46 times by 60. That gives us 2,760 centimeters that are used. And it will subtract that. 2800, take away the answer, is 40 centimeters left over. Question 14. So the table shows the names and areas of 5 lakes. Write the area of Lake Weru, I'm going with Weru, as an ordinary number. So that's this one here. So we've got 5, 1, 2, 0. And I'm just going to check that. So 5.12. Oh, write it correctly. 5.12. If we multiply it by 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, our decimal place ends up there, and our 0 is at the end. Okay, write the lakes in order of their area, starting with the smallest. So when we've got small numbers, we are expecting there to be a lower power because that one's effectively multiplied by 100. These ones are multiplied by 1,000, and these ones are multiplied by 10,000. So our smallest one will be Topo 0. The next one, Tana, because it's got times by 10 to the power of 3, compared to our friend Muweru. That one is the middle one. It's bigger than Tana because it's got a bigger part on the 5.12 element. And then we've got 2 that are multiplied by 10 to the power of 4, but Ladoga. And then finally one I can pronounce, Victoria, goes there. Okay, calculate the difference between the areas of Lake Ladoga and Lake Tana. So Ladoga and Tana. So 1.81 times by 10 to the power of 4. Take away Lake Tana, 3.2 times by 10 to the power of 3. Are we good with that? Yes, super. So difference, that is a subtraction. 1.81 times by 10 to the power of 4, and then subtract 3.2 times by 10 to the power of 3. And then we get 14900. And that's all done through my calculator. Give your answer in standard form. So 1 point, and it wants it to 2 significant figures. So 1.5 times by 10 to the power of 1, 2, 3, 4. And that's our answer. Question 15, a couple of ratio questions. Asmi, Beth, and Callum share a flat. The monthly rent is £760. They share the rent in the ratio 2:3:3. How much does Beth pay for the rent each month? So Beth is in the middle. So 760 divided by 368. 760 divided by 8 is 95. And then the 95 times by 3, which is Beth's share, gives us 285. 285. Okay, Asmi, Beth, and Callum also share the fuel bill in the ratio 2:3:3. Callum pays £33 for fuel per month. That means Beth pays that, but what does Asmi pay? Well, 3 to 36. If we do 36 divided by 3, we find out that that's times by 12, which means that Asmi will pay £24. Question 15, transformations question. So first of all, reflect triangle A in the line x equals 0. This confuses a lot of candidates. So on the x-axis, where it's 0, is all these coordinates up here. So effectively, all of those coordinates are 0 for the x coordinate, making it the line x equals 0. And then we have to reflect that shape in there. So that goes over to there. That goes to there. And that goes to there. Describe fully the single transformation that maps A onto B. So A onto B is an enlargement of scale factor. So we get 1 mark for saying the enlargement. Now the scale factor, 1, 2, 3, 4, 1. So it's shrunk, A onto B is shrunk by a scale factor. So it's been multiplied by a quarter. So you can see this height here is 4 and it's gone down to 1. So it's been divided by 4, making it multiplied by a quarter. Right, finally, where is the center of that enlargement? There we go. If we join up these here, and of course, if you use a ruler, you'll have some success. Better than my one does. It looks messy, but the center point is enlargement of scale factors. Center point at 0, -6. Hopefully that's going to write it in. 0, -6. 0, -6. It's caught up. There we go. Super. And that's our center of enlargement. Okay, question 17. So relative frequency, effectively all of these numbers are going to be the frequency divided by 300, and then it's a decimal. So if I do 57 divided by 300, if you do that in your calculators, you will get 19 over 100, which means 0.9. 42 divided by 300, that gives us 0.14. 27 divided by 300, 0.09. 60 over 300 is 0.2. 39 over 300, 0.13. 75 over 300 is 0.25. Right, so Ling thinks that the dice may be biased. Explain why the evidence from the table could support her opinion. So 300 divided by 6, we'd be expecting 50. So, and then 50, it would be 1/6. What is 1/6 as a decimal? 0.6. So we would expect 0.16 roughly for each outcome. And then I'm going to say 0.25 for a 6 seems too high. And yeah, I'm happy with that. Explain why the dice may in fact not be biased. Well, only 300 trials. More trials are required. So the more you test something, the more accurate your data will become. All right, question 18. A carpenter measures the length k meters of a piece of wood. They write 3.35 is less than or equal to k, which is less than 3.45. Put rings around all possible values of k. So I'm happy with this one. No, I'm not happy with this one. Look at that. That one is less than 3.35. So no good. 3.39 does fall within that, which is good. 3.44 does. 3.45, although it's that value there, it's saying that it's not equal to that, so we can't use it. And then 3.55 is way too big. The carpenter says this inequality means that the length of the piece of wood is 3.4, correct to the nearest centimetre. Explain, how she's correct. Well, the error bound is a difference of 1 centimetre. Okay, complete the error interval for 3.4 metres, correct to the nearest centimetre. So, let me look at that. 3.4 metres. This value here is centimetres. Half of a centimetre is going to be 0.5 there. So that's 0.5. So we add that on. So 3.405. And that is, what was that? Question 18 done. Next video, we'll continue and go from question 19 to finish the paper. But until then, see you next time.